Welcome to Wiki Bearings, where we dive into the worlds of engineering excellence, from the automotive marvels to the industrial giants. Join us to explore the wonders that keeps the world in motion. My name is Hassanein Alwan, and I'm your host. Welcome to another episode of Wiki Bearing. In this episode, if you are looking and working in the heavy industry, crusher, cement, mining, this episode is for you. We're going to particularly talk about spherical roller bearing. And with me, I have an expert that spent 30 years in this industry, knowing it all in the heavy industry, crusher, mining, quarry. He have done it all. He's an expert in not only in spherical roller bearings, but in bearing application. With me, I have Mr. Andre, which is the Amaro Technical Support Engineer for NTN Middle East. Andre, welcome to the show.
Thank you, Mr. Hassanein.
Lots of people look at spherical roller bearing as a very different bearing than any other bearings. And some of them call it the kings of bearings. So where the name comes from?
Well, if you look at the particular design of a spherical roller bearing, what sets it completely apart from most of the other designs is that the bearing consists obviously of an outer ring, an inner ring, two sets of spherical or barrel rollers, as we call them, and a cage. But what makes it very interesting is that in this particular case, the outer ring, if we look at it in cross-section, the raceway is a perfect circle, the center of which is in the center of the bearing. And then into that perfect circle, with the inner ring, with the two sets of rolling elements in the cage, in either the X, Y, and Z axes, the center of those intersecting axes actually forms exactly on the centroid of an imaginary sphere. So you have the outer ring on the sphere, which means this bearing can swivel through 360 degrees in any axis, in any direction that you like. So that brings about a product which is unique in as far as it is able to accommodate very heavy loads. It can accommodate very reasonably good axial loads in both directions. And then, of course, the main property that we are after in these heavy applications is the ability to take a misalignment under load or in dynamic condition, which sets it apart from all the other products.
Now, usually we call the SRB or spherical roller bearings are known for heavy industry. What are the most common applications in the industry?
So if you talk about heavy industries, then we are talking about mining, crushing, quarry, heavy gearboxes, heavy construction equipment, heavy conveyor systems, stacker reclaimers, heavy equipment where the shaft sizes are from 150 millimeters up to even well over 1.5 meters. So this is very, very large pieces of equipment. So the kinds of bearings that we need in these applications, spherical rollers are ideally suited for these applications. So we would expect to find them in all these big or the facilities where you have these big machines, pieces of equipment, plants, whatever. So that's where we would expect to find them.
Now, in recent years, NTN have launched the ULTAGE range. Right. And the ULTAGE range seems to be different from the standard. What makes it so game-changing?
Okay, so the ULTAGE is basically the former standard range of bearings that has been optimized and uprated to the top level. So first of all, the rolling elements have been maximized
Okay.
And the reason for that is so that they can take maximum load. The smaller the rolling element, the less load it can take, the larger it is. Small wheel, small load, big wheel, big load is the analogy I'll use there. So that has been maximized. Also, the number of rollers in the bearing have been increased to fit in the most that we possibly can at the maximum size.
Okay.
Then we've improved the raceway surfaces. So the surface finish of the raceways have been improved. The roughness factors have been improved. The type of material that we are using to manufacture the bearing is also a much better type of material. And also the geometry in the bearing has been optimized. So from a geometric point of view, the dimensions are much more accurate. And so the bearing is able to run at a higher speed, 20% higher than the previous range.
Okay.
They can take 50% higher loads. And of course, they are, with the new cage design, the lubrication circulation within the bearing is also much improved, which means the bearing can be expected to deliver more than double the life in operation compared with the previous range.
So it is a massive improvement.
It is a huge improvement, and also the heat treatments of the bearing has also been optimized in this instance to match with the new materials.
When it comes to the spherical roller bearings, we can understand always they start with 2.2 or 2.3, 2.4, but a lot of engineers sometimes are confused with EAW33 or EAD1. So if you can explain to us in an easy way, what does the suffix means?
Okay, so the easiest way to clear up any misconceptions there is please read the technical literature. So, okay, this is a good question. And it's a very important question because in the industry, especially on the metric ranges of bearings, ISO numbering system applies to all manufacturers across the board.
True.
So the first 5 numbers normally, they are numeric numbers. This defines the dimension series of the cross-section. It doesn't define the internal design, but it just defines the bore, the width, and the OD. So if we look at the numbering system in a 22328 bearing, for example, the 2 is a designated number reserved to identify spherical roller bearings. So all spherical roller bearings from most known brands will begin with the 2.
True.
So then we have the width number, the number which will define the width of the bearing. So the second number 2 means it's width series 2. And that relates directly back to the cross-sectional plan as laid down by ISO specification. The third letter, in this case 3, would determine the diameter series. So we have a spherical roller bearing of width series 2, diameter series 3. Okay, so we know what the physical size of the bearing is. And then the numbers which come, or the alphanumeric numbers, which we call suffixes, which come after the bearing number, the numeric numbers, this will determine the identity of the bearing. It's like a man. We have a man, okay? But that doesn't tell me anything. I need a man. He must have blonde hair, blue eyes. He needs to have a mustache. He needs to be very strong. He must run fast. He must be tall, whatever the case. So these suffixes, as we call them, actually determines or defines the features of the bearing in that particular plan form or that dimension form. So in this case, E refers in NTN's case to the ULTAGE range. E means that the bearing rolling elements have been maximized, so that this is a maximum capacity bearing. Okay. And then also the internal design is changed in as much as there is no guiding ribs on the inner ring. The guiding ring has been removed because we've maximized the rollers. So the A, in this case, as you said, EAW33 or EAD1. So the A refers to the cage.
Okay.
Okay, so A is the designated suffix that NTN have attributed to or reserved for drawn steel cage.
Okay.
So where we have a G15, G15, this is specifically reserved and designates a glass fiber reinforced polyamide cage.
True.
And then we have a third cage designation of M, which designates for the ULTAGE range a high tensile brass one-piece solid cage machined. So then the D1, in the case of the NTN range of bearings that we are offering, this designates there is a lubrication groove in the circumference of the outer ring in the center line with lubricating holes coming into the bearing. W33 is the designation of exactly the same feature, but for the SNR range of products. And then there are further suffixes like C3, C4. So if there's no C designation on the bearing number, then it's a normal clearance bearing, which conforms to ISO specifications. If the clearance is bigger than normal, but in a certain range, that's designated C3. There are specifications and specific numbers to control that range or that class. If it's C4, it means it's bigger than C3, but there's no overlap. So they're stacked on one another. So these suffixes are incredibly important as far as identifying the features of the bearing. Interesting to note, we have up to 35 variants of the same basic bearing.
Okay.
And all the numbers, of course, on the larger sizes not, but on the smaller sizes, like deep groove ball bearings, for instance, we do. There are snap ring grooves, seals, shields, contact, non-contact, C3s, C2, C3, C4, C5. It goes on and on. So you have the same basic dimension bearing
with the different features.
But so many different features. So and the reason why we have the features is the bearing has been optimized or designed for a specific job. So it's very important, and the suffixes are not standard across manufacturers. Each manufacturer have their own suffix codes. There are a few that seem to be convention and used by everybody, like clearance.
Yeah.
So it's very important that you replace the same bearing with the same bearing from different manufacturers.
If we look at the material of the cage, this comes in different material, and how this cage material applies to performance.
So normally we rate bearings in three categories: light load, medium load, and heavy load. So it stands to reason that light load cage or bearings subject to light loads, the cage needn't be the same as a bearing subjected to normal loads, and the cage doesn't need to be the same as bearings subjected to heavy loads. So the function of the cage is only there to keep the rolling element in its center and to control the path around the raceway. The cage is not designed to take any loads or take any vibration, or it's not designed for that at all. It's only designed to keep the rolling elements running in its place, but running true as the inner ring is rotating. So in light loads, which we define as less than 5% of rated load of the bearing, light cages, because the loads are light, so a glass reinforced polyamide cage is sufficient. provided the temperature of operation doesn't exceed 120 degrees.
Okay.
Ideally, above that, polyamide cage is not recognized or recommended. The steel cage, drawn steel cage, is ideal for medium. That's where the load imposed on the bearing is more than 5%, but less than 10% of the rated load of the bearing.
Okay.
And then, of course, for that application, a steel cage is acceptable. But for the heavy applications, which is higher, where the loads imposed are higher than the rated load of 10% of the rated load, we would recommend for certain a brass cage. Because under these high pressures, if you can imagine, the inner ring is pressing towards the outer ring, so there would be a tendency for the rolling elements to separate.
Yeah.
So the cage then, to keep the rolling element in its center, there's quite a heavy rubbing pressure against the cage. And in the absence or in the presence of marginal lubrication conditions, a beautiful steel rolling element rubbing against a softer brass cage, this completely eliminates the possibility of scarring or damage. If it was a steel cage rubbing against a steel rolling element, the onset of damage will be a lot quicker. So for the heavy loads, we recommend brass. For normal, steel, and for light, we recommend polyamide. You can, of course, if you don't have a polyamide, you can use a steel in a lighter load. But if you don't have a steel cage, you can't use a poly cage in the medium load. You can downgrade, but you can't upgrade.
Yeah. Now, if we look at an application demanding like crushers, I think we were talking about it before. It's almost a self-destructing. We at least some people will describe it, and this is why NTN have made a special type of spherical roller bearings known for F800 range. If you can tell us a little bit more about this and what this is different than the standard spherical roller bearings.
Yeah, so this is again a situation where the suffixes play a very important role.
True.
So the EF800 is a bearing, as we call a shaker screen bearing, or it's a spherical roller bearing that has been specifically designed and optimized for vibrator screen application. The only job of an EF800 is in a vibrator screen. You cannot use this bearing in any other application other than a vibrating screen. So the reason for that is it's not a standard bearing. It's not a variant of a standard. Like, for instance, we were talking about 22328 EF800.
Yes.
If I had a 22328 EAW33, they are not the same at all.
No.
Firstly, the dimensions of a shaker screen bearing, they are conforming closely to P4 precision, class P4. So the tolerances of the dimensions is very, very small. So it's an accurate, very accurately manufactured bearing. Also, the clearance inside the bearing is not the standard C4. It's only 2/3 of the same clearance value as an ISO C4. So it's got a much tighter. So both bearings, the only commonality in the clearance is they share the same upper limit of the clearance. Okay. Whereas an ISO C4 is here, a shaker screen C4 would be there.
So it is less clear.
So everything, it's a precision bearing. It's a far more, the dimensions are far more tightly controlled than a standard bearing. Especially also on the inner ring. The inner ring is also very tightly controlled, and that's why you have a lot of problems in the colloquial language used by people. They always talk about, I need a 223 228 shaker bearing or a 22328 C4. They say C4 meaning shaker screen bearing.
Yeah.
Now a C4 bearing dimensionally doesn't fit properly in the housing and on the shaft. And secondly, the clearance might be too small because there's some of clearance which is outside of what ideally is for shaker screen. So this creates a lot of problems. A lot of people, a lot of end users use a standard C4 in shaker screens and can't understand why it doesn't work.
But this means the EF800 would perform much better in the shaker screen.
Well, it's specifically designed for a vibrator application.
Now, so let's say if somebody is using a normal bearing compared to a shaker screen bearing, what are we talking about lifetime here?
Okay, so first of all, the dimensions, the dimensions on the inner ring is going to be a problem.
Okay.
So you'll definitely have an issue with that. And secondly, the clearance. So the mechanism of a shaker screen bearing is not clearly understood. Because if you look at the theory of clearance, the closer you get to zero clearance, the better the life performance you have, to where you have actually a small preload gives you a better life than a bearing with more clearance. However, with shaker screen bearings, quite the opposite happens. The closer you come to zero, the sooner you have a failure. So as through the research and development, it was found that as the clearance range moved into the C4 range, the bearing gave far better results. The only way I can explain that to you is the rolling elements actually bounce and roll within the elastic limit of the inner ring, outer ring, and the thing. So if the clearance is too small, the rate of bounce is too fast, so you get tremendous heat buildup. Yeah. Heat buildup creates expansion. Expansion means you reduce the clearance, which makes it even smaller. So it gets hotter. So the heat then destroys the lubrication, and then you have bearing failure. If the clearance is too big, then you have mechanical damage because you can't get the bounce to happen. Yeah. So within this tightly controlled band within ISO C4, this is the ideal for the bearing size, for the bearing rolling elements to bounce and roll round as the bearing is operating. So,
yes.
So to just put a standard C4 bearing in there, you'll first of all have a dimensional problem, and second of all, you have quite a risky clearance issue.
NTN in recent years have released solid lubrication bearings, and especially for spherical roller bearings, there are some bearings that comes with solid lubrication. How that impacting the performance, and what is the main application for this?
So the spherical roller bearings that do come with solid lubrication are subject to the following limitations. The OD of the bearings is limited to 20 to 90 millimeter, and the maximum width of such a bearing is 65 millimeters. Okay, that in itself is not really such a big thing, but in the bearing application technology, we have a thing called a speed factor, which is the RPM that the bearing will be subject to times the mean diameter, which gives us a factor. And the speed factor for solid lubrication bearings may not exceed 100,000. That means these are all really small little bearings. Yeah. Which don't really come into the spherical range of bearings that we would expect to find in the heavy MRO plants that we are talking about. But it has its place in the lighter industry. Solid lubricant bearings, for instance, their life expectancy is increased by a factor of 20 compared to standard bearings lubricated in a standard way.
Wow, that's a lot.
It's a lot, yeah, sure.
So
The solid lube consists of a polymer material which is porous, which absorbs all the oil. So it's not really a grease. It's like a sponge.
Yeah.
It's like a synthetic sponge, and it absorbs all the oil. So as the bearing is rotating, centrifugal forces, of course, expel the oil into the raceway area where it needs to be. And at the same time, it wipes it and absorbs it back into the sponge. And it remains very clean. The lubrication is where it needs to be all the time. It's well controlled. So this is why we get such a phenomenal life, because the sponge keeps the lubrication in the place where it needs to be.
And it becomes no need for
There's
self-lubricated.
no replenishment required at all, because all the lubricant is in the solid lube carrier sponge, or carrier matrix, if you would.
Now, if we look at the larger spherical roller for the heavy industry, now, if we look at mounting these bearings, could be a challenge because of the weight, the type of application, and so on. So, we have seen, and I think you have seen, lots of mistakes in mounting these kind of bearings. So, what do's and don'ts you would recommend to the maintenance engineer when mounting a spherical roller bearing for heavy duty?
So, let's talk about the don'ts. Okay. So, some of the pointers which maintenance people need to be very careful. Don't take on a job if you don't have the right tools. So my grandfather taught me that if you have the right tools, then half the job is done. So I'm going to teach everybody now the same thing. If you have the right tools, half the job is done. So before taking on a mounting or dismounting job, you need to be sure, first of all, that safety is of paramount importance, that you observe the correct safety protocols. Because some of these bearings weigh a few hundred kilograms, up to nearly 1 ton on the larger sizes. You need to be able to handle a mass of that magnitude easily. So you need proper craneage, you need proper rigging, you need proper strapping, lugs, eye bolts. You need to be equipped to handle such heavy loads. Secondly, if you haven't done the mounting and dismounting of big bearings like this on a regular basis, it's best to leave it to the experts. So that's why in cases like this, definitely don't do the job on your own if you don't have the right equipment. So the do's would be, please do contact NTN to advise you or to technically support you or to recommend what you should be doing or how you should doing it, but most of all, to evaluate whether or not you can do this job or not. There are several workshops that claim to be able to do these jobs, and we are in a position to recommend where you can have such works done.
Now, if we look at these kind of heavy duty, usually they are in harsh environment, dusty, contamination. If we look at the crusher, a cement plant, a quarry. Now, in the latest generation of bearings, there have been lots of talk about seal bearings, and it's very normal in a ball bearing that we have seen that a lot, but in a spherical roller bearing was not very common, but in recent years it's becoming more common. Would you recommend seal bearing in this kind of application, or when do you recommend sealed spherical roller bearings?
So here again, sealed spherical roller bearings are very, very good solution in certain application problems, but they do come with some drawbacks.
Limitations.
Yeah, they do have some drawbacks. So the first thing is that you should know about sealed spherical roller bearing is that they are not a standard width. So because they're not a standard width, if you want to use these bearings, you need a special custom locating ring. And if they are mounted with adapters or with withdrawal sleeves, you need a special withdrawal or adapter to accommodate the extra width.
Okay.
So that is a drawback. It's not a drawback that will kill the idea, but it is a drawback. The positive attribute of this kind of bearing is that below 70-degree application temperature, there's no relubrication required for this bearing.
Okay.
However, the range of bearings that come as sealed spherical roller bearings is from 35 millimeter shaft to 90 millimeter shaft.
Okay. So
once again, they are not really in the I would say they're not really in the scope of bearings we would expect to find in crushers. However, on the conveyor belting systems, they can be a very, very good solution because the shaft sizes of conveyor belts are anywhere from 50 millimeter to 100 millimeters. So there are plenty of conveyor belting applications that they would work. And the RPMs are really low. They seldom run more than 100 RPM, which is slow.
Ideal.
And the bearing is ideal. It will never run hotter than 70 degrees. So you can put it in just as you would a normal deep groove ball bearing that has been sealed with its lubricant. You could use such a spherical roller bearing and never have to lubricate it.
And in this case, in these conditions, would be an advantage. No real lubrication. It's almost as.
This is the biggest problem in crushers and quarries and cement plants, because because of the dust and difficult environment. What kills most bearings is contamination in the grease in these industry segments. So we have to try and keep the bearings, the lubricant, as clean as possible. That means your sealing arrangements need to be working, need to be in good condition. But sadly, this is not something which actually is happening in the industry now.
Yeah. Now, if we look at the axial and radial loads, now these heavy-duty industries, and I think there is a lot of misconception about what and how this axial and radial loads are dealt with in a spherical roller bearing in this shocking application.
Okay, so a spherical roller bearing has a perfectly circular curve to the raceway on the outer ring. It's a perfect circle. Okay, so because of that, the bearing is able to take, and it's got two sets of rollers, which means it is highly adept at handling heavy radial loads. And radial loads, when we talk about a radial load, we're talking about a load that runs through the center of the bearing through on a radius. Radial radius. Yeah, so from radially in any direction, if the bearing can take which is at 90 degrees to the shaft or the axis. Okay, it can take a very heavy radial load. But because of the geometry of the bearing, it is also able to handle quite a good axial load in both directions. They're quite good at doing that as well. However, there are certain conditions to that, because if there is a radial load only, well, this is not an issue when we are selecting a bearing. But when there are axial loads, now it becomes a little bit complicated, because we have to find the equivalent radial load. Because if there is an axial load, because of the curvature of the raceway, we get a component. So the axial load might be a magnitude 10 example, But because of the curvature of the raceway, the component, then it adds an additional, let's say, just for example purposes, a magnitude 50 radial component, which is added to the existing radial component. So one has to do proper calculations to establish what it can do. So we have an E factor in the technical literature of our catalogs, which is a factor which is a, let's say, a transition point. So what we do then is we will do a ratio of the axial load over the radial load. And if that is less than or equal to the E factor, then it has no effect in the equation, which is X radial plus Y radial. So it has no effect on adding or the component, the radial component of the axial load. However, if the ratio of F axial to F radial is more than the E, then it does have an effect.
That need to be calculated.
And it has to be as
radial.
per the technical information. So it adds a 0.67 of the axial load is added as a radial in when we are the equivalent load. Because it's a vector. It's basically a vector calculation. If you have radial and axial, then we have to calculate the resultant. So basically, you have a radial load with an axial load. So you will then have a load effective on the bearing, which is in this direction. And this is what makes spherical roller bearings also stand out from everything else. Because of the spherical raceway, it can work in any direction and accommodate the loads with quite good ease.
You know, this is where if we look at this bearing and their ability to take misalignment is what's set them apart. So if you tell us a little bit about the possibility of taking this misalignment, because also there is a thing, yes, they can misalignment, but I think we cannot consider this bearing to take a lot of misalignment. I think there is a limitation
that's
there.
True. So misalignment can be misunderstood. But in engineering terms, when it comes to bearing application, we are working with microns. So microns, a millimeter consists of 1,000 microns. To bring it into perspective, your hair is 100 microns. So when we are working with these small numbers, in reality they are small, but in bearing application technology, they're quite large. So for us, 20 microns could be the difference between failure or success. So 20 microns is your hair cut into 5 slivers, and one sliver is 20 microns. So while it's in reality minute, for a bearing, it's a huge number. It's a big deal. So also with the misalignment, a spherical roller bearing, if it is lightly loaded, it can take up a misalignment of almost 2 degrees. 2 degrees. If it is normally too heavily loaded, the misalignment is limited to a half a degree. Okay. So that might, it's only 2 degrees. Oh no, it's only half a degree. That's what benefit is that? Well, in engineering terms, in bearing application technology, half a degree misalignment is massive. So when the designers of the equipment design the machines, they're very much aware of shaft deflection and misalignments and bending moments. So if the bending moment or the deflection is too much, that means the stresses on the shaft go outside the limits. So if they observe normal design criteria where the bending moment in a or the bending stress in a shaft does not exceed 165 megapascals. You don't even get any. You're talking about minutes of deflection, not even degrees. So we're talking here. Half a degree is 30 minutes of deflection. Okay, and we're maybe talking about 2 or 3 minutes of deflection. So it's massive.
Yeah.
You never get there.
You know, when we look at the degree on a maybe normal life, we say 1-2 degrees is, but in a bearing business, in a shaft alignment, in a machine, 1 degree is already a lot.
So let me put that in another way. If I'm an engineer and I've been contracted to do a job, and I am 2 degrees out of alignment, I will be fired as being useless. So 2 degrees misalignment capability is very, very comfortable and very generous. In engineering terms, in reality, we are working in microns of misalignment. So the bearing is able to, that's what makes spherical roller bearings the bearing of choice in heavy applications, because you just can never get anywhere near the limitations of the bearings if they're selected and sized correctly.
If we now, you have spent years and years in such heavy industries, and so can you give us some real case scenarios where you switch from one type of bearing to another type of bearing, maybe from another brand to an NTN bearings, where the life expectancy changed massively?
So if I honestly answer this question, I have to say that in virtually every application case, end users are not getting anywhere near the designated life that the bearing is designed to do.
This is a good remark for the maintenance engineers hearing us, the plant managers, and because I think we are nowhere close to the maximum life of bearings.
Right. So this is as I said, no end user is getting anywhere close to what the bearing is supposed to deliver, and that's because of a whole host of errors and a comedy of errors which happen in the life of a bearing. We have got cases where there are several cases actually where we have converted end users who were consuming 24 bearings a year on 6 similar equipments.
24, so 4 times a year.
So every 6 months they had to replace the bearings, yes.
Okay.
And as I sit and speak to you here today, we have just crossed 43 months of continuous operation at that same plant with the same bearings that we installed.
43 months.
43 months. So my pledge to them has been they will reach an operational life of 48 months. And then even after 48 months, I won't be nervous yet, or I won't be afraid of a failure just yet. And that's only because they are using the correct dimensions, the correct bearings, and they have mounted the bearings as per our recommendations, under our supervision. I've trained their staff to do the job correctly, and most importantly, they are using the lubrication that we recommend.
So let's say, what are the most common cause of failure, and can this be prevented?
Oh, absolutely, it can be. The most common cause of bearing failure is the lubrication. Why do bearings fail? It's the lubrication. Something to do with the lubrication. So it's either too much, too little,
The wrong
too
one?
erratic, completely wrong lubricant, or fake lubricant, incorrect amount.
Contaminated lubricant?
Contaminated lubricant. But by far the majority cause of failures is contaminated lubricant. How do we know the grease has been contaminated? When the color has changed. Grease that is contaminated will appear black. Grease that is not contaminated will be the same color as it was when you administered the grease or fed the bearing with grease. The reason why contamination is the overwhelming reason for not bearing failure, but bearing damage, early bearing damage to the point where it can't operate anymore, is because of the people responsible for the lubrication. They don't observe the dosage recommended. So you can't. They pump grease into the bearing until they see grease coming out somewhere. And the reason for that is because nobody is going to blame the guy who's doing the lubrication that he didn't do his job. They did it only once. He nearly got fired. They said to him, "You didn't grease the bearings." And they will never say that to him again. So he will make sure you can see grease coming out. They will never accuse him that he didn't do his job. But of course, when grease is coming out, that only means that the seals have been blown out or they've been sheared. So now, of course, the contamination will get in there, and that's purely due to complete ignorance and lack of understanding what we are doing. So no, if we do all those things correctly and we monitor everything correctly, yeah, I expect 48 months quite soon. I would like to put on record that there is not one single crusher or quarry plant or cement plant in the entire UAE, I would say, that can say that for 43 months they haven't had a single bearing failure anywhere. And my challenge to anybody out there is go and try and sell them something else other than NTN or SNR and see how far you get.
I think at the end of the day, it is like a puzzle. You have to complete the whole. The right bearing, the right way, the right mounting, the right grease. It's the whole thing that makes the bearing last, and it's not just one thing. And this is why we as engineers have to understand that if we put the bearing in a perfect condition, if there is a perfect condition, I think we can get the most of the life.
You get the perfect result.
Yes, exactly. Now, I think you mentioning how important is the right type of greases. Now, when in a shaker screen where there is a lot of vibration, is there a grease that can work in such an environment?
So there are lots of lubricants available on the market, and there are lots of lubricants that have been used that work very well. But for optimum results, NTN does manufacture and offer a range of lubricants for a range of applications. The lubrication that we recommend for the heavy industry segments like mining, crushing, quarrying, we have a lubricant which is a VIB. We call it, the designation is VIB for vibration. And that lubricant is recommended for all production equipment. That's cone crushers, jaws, impactors, shaker screens, all equipment that is crushing rock or involved with crushing rock. We recommend the VIB grease. The base oil viscosity is particularly favorable for these heavy applications at 360 centistoke. And then, of course, there are special additives and extreme pressure and vibration and shock kept very, very classified. No, we don't. The ingredients are not disclosed anywhere, although they conform to all non-toxic and safety criteria. They're not toxic or poisonous. But of course, the grease is completely designed for these heavy applications. Then we have other greases which are for heavy duty, but not vibration or shock. And then we have universal grease, which is for usual light duty grease. We have high temperature greases. We have high speed greases. We have food grades and so forth. So my advice would be, if you want to have the kind of performance that I'm talking about, first of all, you need an NTN bearing. Then you need NTN technical support. And then you need NTN lubrication. And then most of all, you need NTN supervision. So yes, then you also could have 4 years of not a single lost production hour because of a breakdown, a bearing breakdown.
Amazing result. Now, for all the engineers listening to us, the plant managers, the engineers, the maintenance, I mean, we can go on this topic. I mean, spherical roller bearing is a very interesting topic. But let's say to the end of this podcast, what would you say to this engineer before they order their next spherical roller bearings?
So the most important thing when you're ordering a bearing is you need to make it quite clear what the application is. What is the application of the bearing? You need to communicate the parameters or the concerns or the reasons or all the
pain.
Yeah, all the facets that are connected to this, the reason why you want to replace the bearing. What is going on? What has happened? What do you suspect? And so forth. Then the next thing is ask NTN to do a failure analysis for you. Because if you don't know what has gone wrong and you put a new bearing in there, you will just repeat the same next time. Oh, the same thing has gone wrong. The same thing has gone wrong. So bearing application technology is not a hit and miss or a fortuitous event. There are 3 things which are prerequisites. Okay, you have to have the right bearing for the application, and there is a bearing for every application. Sure. You have to have the right bearing for your application. The second thing is you have to have the right dimensional fit and tolerances for your housing and your shaft for that application. And then the third thing is you need to have the right lubrication for that bearing. And when I say the right lubrication, I mean the right type of lubrication, the right amount of lubrication, the right relubrication sequence, and this needs to be observed, the right amount of the right grease at the right time, after the right amount of time, every time. So then you will have success. And the ability to do that is not taught in any university or any college, and you cannot learn this by experience. You can only have the benefit of these informations from a manufacturer.
Because they are the expert in this.
So yes, all the lubricants that we offer have been tested exhaustively on our products. So when we make statements about our grease in our bearings, in your application, this is not conjecture, it's fact, because it's been tested over and over again.
True. Mr. Andre, it was very nice talking to you. It is a pleasure. Suddenly, spherical roller bearing is so interesting, much more interesting than any other bearings, even though all bearings are interesting. Thank you for today. It was really nice to have you on our show, and maybe we have you on another time on another bearing.
It would be my pleasure to share what I know with all of you, yes.
Thank you very much. And if you have any comments or recommendation, email us at podcast@mcb.ae. And that wraps another episode of Wiki Bearings. Don't forget to subscribe for more insights into the fascinating realm of the engineering innovation. Until next time, keep spinning towards greatness.